Hi, today we're going to be learning about equivalent forms of relationships. First, let's really talk about what we mean when we talk about equivalence. When two expressions are equivalent, it means that they have the same value or they will yield the same result. If two rules are equivalent, they will give the same output values for matching input values. There are two methods that we can use to determine whether rules are equivalent. The first one we're going to look at is determining equivalence by testing outputs. What this means is we can work out if two rules are equivalent by testing them with different inputs and finding out if the rules give the same outputs. If they give the same outputs as each other, then that would indicate that the rules are equivalent to each other. So here's our first example for today. Rectangle 1 has a length of 8 centimeters and a breadth of 5 centimeters. Rectangle 2 has a length of 10 centimeters and a breadth of 7 centimeters. We need to show that the formulae P equals 2L plus 2B, that the perimeter is 2 lengths plus 2 breadths, and P equals 2 times in brackets L plus B, that's the perimeter equals 2 times in brackets the length plus the breadth, are equivalent by calculating the perimeter of both rectangles with each formula and comparing the results. Okay, so what I'm going to do for this example is I'm going to take the two rectangles, so we're going to work out over here for rectangle 1, so I'll do this over here, rectangle 1, we're going to work out the perimeter using both of the different formulae and see if we get the same result. So the first formula is P equals 2L plus 2B. Okay, so the perimeter is 2 times the length of rectangle 1 is 8, plus 2 times the breadth of rectangle 1, which is 5. Okay, and that gives us 16 plus 10, which is 26, and it is centimeters. Okay, so for rectangle 1, using the first formula, I get 26 centimeters. And then using the second formula, P equals 2, and then in brackets L plus B. So that's going to be 2, and then in brackets I've got L, which is 8, plus the breadth, which is 5. And if I simplify that, that's going to give me 2 times 8 plus 5 is 13. 2 times 13 is 26 centimeters, which is the same as what I got using that formula. Okay, so based on what I can see for rectangle 1, it looks like these two formulae would be equivalent. Okay, now I can't just stop there. You can't prove equivalence just by doing one test, because sometimes a formula will work, or two formulae will give you the same result for one test for one set of inputs, but it'll give you different results for another set of inputs. So you need to make sure that you test with at least 2, preferably even 3 different things. But in this case, because we have 2 inputs in our formula, we can keep it down to just 2. Okay, so I'm now going to do my second test, which is going to be testing with rectangle 2. Now this doesn't need to give me the same perimeter as what I had for rectangle 1, because this is a different rectangle. But what I do need to be able to see is that if I use the two formulae, I should get the same result for the perimeter using both formulae for this rectangle. Okay, so over here, using the first formula, P equals 2 times the length plus 2 times the breadth, I get 2 times the length of perimeter, or the length of rectangle 2 is 10, plus the breadth of rectangle 2 is 7. That gives me 20 plus 14, which is 34 centimeters. Now, like I said, these do not need to be the same because they're different rectangles. I don't expect them to be the same. But when I use the other formula for rectangle 2, I should get the same result as what I used with this, as when I used this formula. So over here, P equals 2 times the length plus breadth in brackets. That's 2 times the length is 10 plus the breadth is 7. So that's 2 times 17. 2 times 17 is 34 centimeters. So yes, I do get the same answer. So now because I did 2 tests, and in both tests with different inputs, both formulae gave me the same results as each other. Okay, that means I can now say, therefore, this formula is the same as that formula. They are equivalent to each other. Now, I don't have to worry so much about the P, because the P is the same for both. But it's this part, the rule that actually tells me how to work out P. Are they equivalent? So now I can say this, then yes, 2 lengths plus 2 breadths, 2L plus 2B is equivalent to 2 times the length plus breadth in brackets. They give me the same result. It doesn't matter which option I use, I will end up with the same result. And that is what it means when they are equivalent to each other. It doesn't matter which one you choose, they'll give you the same result. Okay, so that is how you can prove that two rules or two formulae are equivalent. You can do it by testing with inputs and see if they give you matching outputs. Okay, so now I'm going to give you a few that you're going to do for yourself. The first one you're going to do is this one over here, where you've been given 2 rules in the form of, or being represented in flow diagrams. You need to work out for each of these rules the outputs where you've been given these inputs, -1, 0, and 1. And here you also have -1, 0, and 1. Now it's important that the inputs here and the inputs here are the same, because you can only compare when you're working with the same inputs. Just like when I was doing over here, this example, I couldn't compare these to each other because my inputs were different. Here, my inputs for length was 8 and breadth was 5, and here the length was 10 and the breadth was 7. They were different inputs, so I couldn't compare them and see were they the same. No, I was comparing these ones and I was seeing where I had the same length and same breadth, did I get the same perimeter? Yes. Where I had the same length and same breadth, did I get the same perimeter? Yes. So because I had the same inputs in these and had the same inputs in these, I could compare the outputs and I could see if they were the same. So over here, when I'm doing this example, I'm going to be comparing the outputs where the inputs are the same. So I'm going to be comparing the output for this one and the output for this one over here and seeing if these 2 outputs are the same. Then I'll be comparing and seeing if this output and that output are the same because the inputs are the same. I'll be comparing and seeing if this output over here and this output over here are the same because these 2 inputs are the same. So that is what I'm going to be comparing. I'm going to be comparing to see if the outputs for the matching inputs are the same as each other. And if all 3 outputs over here are same as all 3 outputs over there, because the inputs are the same, I can then say that the expressions are equivalent. Okay, so that's what you're going to be doing now. You need to go and work out these outputs and see if they mean that these 2 expressions over here, these 2 rules, are equivalent. Okay, so I'm going to give you 2 minutes to work on that example. Okay, so let's see what you should have got for that. So first of all, you should have found that with this one over here, if your input was -1, your output should have been -12. If your input was 0, your output should have been -7. And if your input was 1, your output should have been -2. So that's what we should have got for the outputs over here. Then for this one over here, if your input was -1, your output should have been -11. If your input was 0, your output should have been -7. And if your input was 1, your output should have been -3. Now, I want you to take note over here that if your input is 0 over here, you get -7. And if your input is 0 for this one, you also get -7. However, the other outputs do not match in these two rules. So that's why in the last example I said you can't just base it on one test, because sometimes one test may yield the same output for that one particular input, but if you test with other inputs, it might not match. And that means that they are not equivalent. Over here, because all three of them are not equivalent or the same output, you can't say that these two expressions are equivalent. They can only be equivalent if all of the outputs match there and there when you're working with matching inputs over here. So in this case, I'm going to say that 5x minus 7 and 4 times x minus 2 plus 1 is not equal. They are not equivalent, okay? I cannot say that they're the same because they do not yield the same outputs in this example. Right, now I'm going to give you another one that you're going to work on. So over here, you've got your rules being given to you in the form of a table or in the form of tables. And you need to work out once again with these inputs, -1, 0, and 1, and the same inputs over here, -1, 0, and 1. Remember, you can only compare when you are working with the same inputs, okay? So over here, you're going to work out the output values for this formula, and you're going to work out the output values for this formula, and you're going to then see if these two are equivalent to each other. So I'm going to give you 2 minutes to work on this one as well. Okay, so let's see what you should have got for that. So first of all, you should have found that your output value for this rule over here, if your input is -1, your output should have been -2. If your input was 0, your output should also have been 0. And if your input was 1, your output should have been 4. Then for this rule over here, if your input was -1, your output should have been -2, the same as it was over there. If your input is 0, your output should also be 0, the same as it was over there. And if your input was 1, your output should also be 1, the same as it was over there. So now because you can see that for the same input values, the output values are all the same as each other for the two different rules. That means I can say that this rule over here, x times x plus 3 in brackets, and this rule over here, x squared plus 3x, are equal to each other. They are equivalent. They will always result in the same or they will always give the same results. Okay, so that is the one way of determining equivalence of rules. You can determine if rules are equivalent by testing them, by using input values and testing and seeing what output values you get for the two different rules that you're checking, and see if the output values that you get for the two rules using the same input values are equal to each other. And if the outputs are the same for the two different rules, that means that the rules are equivalent. But remember, you can't only test with one or even only two, because sometimes if you test with two inputs, you might get the same outputs, and then if you test with a third one, you might get a different. So long as all of them give the same outputs, then you can say that they are equivalent to each other. Okay, so now let's have a look at our other method of determining equivalence. And this is to determine equivalence algebraically, using what we already know about simplifying expressions algebraically. Okay, so here's the first example that we're going to do. It says, use algebraic methods to show that the formulae P equals 2L plus 2B and P equals 2 times L plus B in brackets are equivalent. So now we've already used the other method for these two formulae. Now we're going to do the same two formulae, but we're going to prove it using algebra. Okay, so I'm going to go and do this over here. So first I'm going to start with my first formula is perimeter is 2L plus 2B. Now I can't really do anything with this. It's already in the simplest form. I can't add anything, can't subtract anything, I can't multiply anything, I can't do anything more with this. But if you look at the second formula, P equals 2 and then in brackets L plus B, I can simplify this over here. I can multiply in. Remember, we've learned how to multiply into brackets, where we multiply the 2 by that and multiply the 2 by that, and then we get over here 2 times L is 2L plus 2 times B is 2B. Now because both of these end up looking the same, that means that they're equivalent to each other. So if you are able to simplify both expressions, in this case I didn't need to simplify this one, sometimes you will, sometimes you won't. But if you can simplify both expressions and they end up looking the same as each other, that means that they must be equivalent. So therefore, this over here, 2L plus 2B, must be the same as that over there, 2 times L plus B. Okay, so that's another way of determining whether or not expressions or rules are equivalent to each other. Okay, so now you're going to do a few for yourself. Here's the first one you're going to do. Use algebraic methods to determine whether the following pairs of rules are equivalent. This one you're going to be doing is y equals 3x plus 8 and y equals 3 times in brackets x plus 2 and then plus another 2. Okay, so you need to simplify algebraically and then see if you end up with things that look the same. Okay, so I'm going to give you 1 minute to work on this question. Okay, so let's go through that example. So over here, my first equation was y equals 3x plus 8. Now this I can't simplify. There's nothing I can really do with that. But let's go and have a look at the second one. Y equals 3 and then brackets x plus 2 and then plus another 2. Now this I can simplify. I can multiply the 3 into these brackets. 3 times x and 3 times 2. So that's going to give me 3x plus 6 and then plus this other 2 over here. Now I can go and simplify that. 3x, and then plus 6 plus 2 is plus 8. Now if you look over here, 3x plus 8 is the same as the 3x plus 8 that I had over here. That means that these are equivalent to each other. So now I can say, therefore, 3x plus 8 is the same as 3 times x plus 2 in brackets plus 2. They are equivalent. Okay, so that's the first example. Now the last one we're going to be doing for today. You need to do the same thing, but your two expressions this time are a little bit more involved. Okay, so I'm going to give you 1 minute for this one as well. Okay, so let's go through that example. So in this example, we had y equals 3, and then in brackets 2 minus 3x, and then plus 2x. And we had y equals x plus 2, and then in brackets 5 minus 4x, and then minus 4. Now, you don't have to write the whole equation when you're doing this. You can just write the right-hand side part of it, because the left-hand side, the y equals, is not what we're testing. We wanted to know if the right-hand side is equivalent, which is how we find out what y is. Okay, so I'm just going to write 3 and then 2 minus 3x plus 2x. This is what I'm testing. I want to know if this is equivalent to x plus 2 and 5 minus 4x minus 4. Now, if you write y equals and y equals, it's fine. Okay, but you don't really have to. You can just work with this over here, because this is what we're testing. We want to know, is this equivalent to that? Okay, so over here I can simplify this by multiplying the 3 into the brackets. So 3 times 2 is 6, and 3 times negative 3x is negative 9x. So that's going to be 6 minus 9x plus 2x, which I can then simplify by adding my like terms. 6 minus 9x plus 2x is minus 7x. Okay, so that's what I get when I simplify this one over here. Now let's have a look at this one over there. So now the x is going to stay as it is. I'm multiplying the 2 into the brackets over here like that. Okay, so I'm going to have x, and then 2 times 5 is positive 10. 2 times negative 4x is negative 8x. And then I've got my minus 4 over there. Now I'm going to go and simplify this. Now I want to see if it's going to end up looking the same as this. So because this one I wrote with the constant first and then the term with x in it, I'm going to write these in the same order over here to see if they look the same. So I'm going to do my constants first over here. 10 minus 4 is 6, and then x minus 8x is minus 7x. So these two do end up looking the same. So now I can say, because they end up looking the same, therefore this expression, 3 times 2 minus 3x in brackets plus 2x, is the same as this expression, x plus 2 times 5 minus 4x in brackets minus 4. So those are equivalent to each other. So that's what we should have got for that example. And that is how we determine whether or not rules are equivalent to each other. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.